And I promoted him to talk and promoted to panelist. Okay.
Have you
Maybe
done?
now he appears. Sebastian, okay, you are here now.
Oh, fine.
So you can start.
Hello.
Ciao. It's great to have you here. Okay, you can start.
Oh, thank you. Sorry very much because of this. I'm very sorry. Okay. Well, firstly, I want to thank you for the opportunity to be here in the presentation for your passion. I'm really sorry for that. So can you hear me well?
Yes.
Okay. Well, I'm going to show you the results of my research for undergraduate student in biology. The research is passive acoustic monitoring for identification and location of a migratory fish spawning areas in a tropical Andean river. My name is Sebastián Muñoz. As an introduction, I want to tell you that in Colombia, there are a lot of hydropower interest. And in recent years, there has been a lot of construction on new dams, and there is a lot of new dams projects in the area, especially in the Magdalena Basin or Andean region. And this is a real problem for migratory fish species because this dam has interrupted the natural routes, migratory routes, and also there is a loss of the spawning grounds in this kind of fish. One of these migratory fish is Procylus magdalene or boca chico. This species is the most important inland species for fisheries in the country, and at this moment, this species is facing reduction in the populations. So, since this species can make sounds in reproductive behaviors, we want to take advantage of this. So it's like an opportunity to locate spawning grounds using passive acoustic monitoring, and that was our objective, to characterize these sounds and use for locate these important areas in these species in the region. This space, in a very general mode, we started with a characterization with captive animals. After the characterization of the bioacoustic signal was done, we went to the field and we make some samplings. And again, we compare with the.
Sorry, Sebastian, do you have a presentation?
Yes, yes.
You have to share your screen.
But oh no, I can't believe it. Now?
Yes, now it is perfect.
I'm really sorry. Really sorry. So I'm going to go very fast to the.
Yeah, okay, don't worry.
Well, I just wanted. Sorry. Well, here, this is the Magdalena area, Magdalena Basin, where this fish occurs. This is the fish, and here I wanted to say that in the material method, very general, we went using captive fish from natural populations, and we try to validate the passive acoustic monitoring use with those characterization. So in the acoustic characterization, we use a total of 47 males from natural populations, and they were combined with females. We use some mirror and hydrophones, and we use a total of 1 hour long by male. This hour was determined by with the projected time where the reproductive behavior occurs according to the fish farm we visit. For the analysis of the data, we use Avisoft SAFLab probe, and we use a sampling rate of 12,000, very large, because normally fish produce low frequency sound, but because we have no reference for this species, we want to be conservative and avoid to lose any possible information. The bioacoustic variables we measure dependent of the kind of acoustic signal. So we have simple pulse, and we have here 3 variables, and in the next table we have variables that we measure for train of pulses. Temperature and also standard length and the expression were recorded. We use means values of the acoustical variables, and we made descriptive statistics for the variable we evaluate. We also made oscillogram, spectrogram, and power spectrum for characterizing that signals. And here we have some of the examples of the way we determined the variables. For the field sampling, we visit 13 places recognized by artisanal features that help us to go to visit the places that where the spawning grounds of this species are, so we can validate what we found in the captive conditions. We have reference J, and here we have the map of the places we visit in the Cauca River, Nechi River, and Magdalena River in the northern Colombia. We use statistics and comparison as described for fish in captivity when it was possible. And as a result, here I have the sound of the fish. An example, I don't know if you can hear it. Do you hear?
No.
Okay, in here.
Yes.
Okay, this is a very simple call, and in this case it's a train of pulses. In total, 27 captive male produce sounds, and 20 of them produce train of pulses. Total, we recorded 1,523 acoustic signals, and 211 were train of pulses. We find no linear relationship between standard length and dominant frequency, which is very surprising, because normally we expect that a larger animal have a lower dominant frequency, but in other studies in Brazil, they found that for Procylodontids, this kind of family of fishes, have similar results in relation with the standard length. Also, we have no relationship with temperature and acoustic variables. However, it's very important to measure temperature effect in the rate of pulses in the animals. Here is very interesting finding very interesting that there was no egg detection in absence of male sound. I mean that we didn't find that females fish spawn with no male sounds. So this gives us an idea of the importance of these sounds for this species in the reproductive behavior. Here in this oscillogram, we can see a general waveform of the train of pulses, and we can see that at first the pulses, the signal increasing in energy, and with the time it starts to descend, and in the more detailed oscillogram, we can see that there are two dominant dominant peaks for each acoustic signal. In the spectrogram, we can see that the dominant frequency for the sound of this species is more near to 400. Actually, it's 399 hertz. So it's a low frequency sound. And also in the power spectra, we can see that the energy is concentrated in low frequency values. In the case of the visits in the fields, we have 6 events in the S6 site and 18 events, and this is called events, but because we find like a chorus of sounds, so there were a lot of these fish making sounds, and that's make very difficult to analyze these sounds. So at the end, we decide we only could analyze the start and final fragments of these events because they have a clear signaling. So this was one of the most important limitations for us in analyzing and validating the PAM in the field. In general, there is here a lot of information, but for summary, we can see that for captivity, pulse and duration and peak frequency is similar. Pulse duration and peak frequency for Boca Chico is similar between the captive animals and the field animal, but here we find like another conspicuous signaling. And according to the artisanal fisherman, this belongs to another species. And in the results, we can actually see that there is an important variation in peak frequency. It's almost doubling the peak frequency of Boca Chico. Also, the interpulse interval is huge, is larger, and this shows that it's possible to differentiate to these two kind of fishes. So, in conclusion, we can say that PAM or passive acoustic monitoring can be used to locate natural spawning grounds of this species. However, it is necessary to refine the application of this tool by improving the recording and analysis approach of these species choruses, because it's, to us was difficult. And with this improvement, we expect that this tool can be very helpful for studying not only Proclidus magdaleni, but also other species in the area that use different migratory routes and spawning areas that are under threat at this moment because of the hydropower development in the country. So I want to thank you, Nature Conservancy and the Fundación Mario Santo Domingo and the group of Physiology of Universidad de Antioquia. And I want to thank you for being here in the presentation. I apologize because of the initial problems. And that's it. Thank you very much for your attention.
Thank you, Sebastian. You are in time, so we have time for one question, at least one. I don't see any rising hand. I just have a question related not to acoustics, but how these environmental transformations are managed. In many cases, at least in Italy and in Europe, when we have dams that may block the water flow on a valley, we try to have a derivation of something, a limited flux of water to maintain the water flow, the natural water flow, and also we may consider special corridors to allow fishes to migrate. Is this happening in your country?
No, in Colombia, there is no a stairway for fish. There is no this kind of helping measure for let the fish to continue the migratory routes. The more near cases in Brazil. In Brazil, they have some dams with this kind of fish passage. However, there have been some bad results because many of the native species have no use in this, but the exotic species. So it's very important to contextualize the solutions that have been applied in the northern area that not necessarily function in the tropical region.
Okay, I thank you for this answer. It's a bit worrying, but it is everywhere a big problem. So I have to ask to the speaker to show up. And the next speaker is